In this episode, we'll look at the recently launched Cloud Run beta. It's a managed service that runs stateless containers invocable via HTTP requests. Also, we'll be looking at differences between Cloud Run, Lambda, and Fargate. There will be demos too. The reason I wanted to check out the beta of Google Cloud's Cloud Run is that there's lots of innovation happening in this space around the single instance managed container stuff. I like to check out these new tools when they come out because you never know when you'll find a use case for them. The core idea is that you tell Google Cloud that you want to run one of your containers with a specific amount of CPU and memory, and they'll look after all the gory details behind the scenes. You don't need to worry about orchestration and all the other infrastructure stuff, which is pretty neat. But the really cool thing about this is that you only pay for the amount of CPU, memory, and other network resources that your container is using while servicing your requests. Other than that, you don't pay for anything. So this can be extremely economical for certain types of workloads. Before we dive in, I wanted to chat about where I see Cloud Run fitting into the larger container and production map. If you haven't seen this map before, it's sort of a high-level map of where I see DevOps tools fitting into the ecosystem. So at a high level, I see Cloud Run fitting in around this orchestration category. But we're not actually the ones running these containers. We pass all that over to the cloud provider. Actually, I should probably add a new serverless category here, and I'll add some tools under that. Personally, I like to find out how new tools are similar to what I already know, then it sort of speeds up the learning curve. So let's do that. For me, I see many similarities between Cloud Run and things like AWS Lambda, AWS Fargate, and Google Cloud Functions. But how is Cloud Run the same or different than these other products? Well, I'd put these four products into two broad categories. First, you have Functions as a Service, and I see both AWS Lambda and Google Cloud Functions fitting into this category. You basically just define the functional code you want to deploy, things like sending emails, converting images, processing messages in a queue, etc. And the cloud provider handles all the behind-the-scenes stuff for you. You only pay for what you use too, so you don't have a bunch of infrastructure sitting around idle. This is sort of serverless in a nutshell. Well, there are servers, just not your servers. So you're serverless, not them. However, there's limitations to this. For example, AWS Lambda and Google Cloud Functions both have limited code execution times. Lambda supports 15 minutes, Google Cloud Functions support 9 minutes. After these timeouts, your functions are terminated. Both also have a fixed number of languages they support, so you can't just run any old code or custom libraries you want. Next, there's concurrency limitations on how many requests you can actually send to these functions at once. Finally, there's also limits on how much CPU and memory you can assign to these things. There's other things too, but this gives us enough information for now to see how things like AWS Fargate and Google Cloud Run are different. So this mental model is what I think of when people say functions as a service. So where do products like Fargate and Cloud Run fit in? Well, this is what I think of as containers as a service. It looks very similar to what's happening above here with functions as a service. We're doing something very similar here. We're asking a cloud provider to run some of our code, but this time it's packaged in a Docker container. Plus, there are differences from the above limitations. Instead of having an execution limit, there's no limit. You're just charged by the amount of CPU, memory, and other resources you use, things like networking, etc. Next, you can use any language, code, or supporting libraries you want because this is all wrapped in a container, which you have full control of. I'll show you this in the demos later. There is also a much higher request concurrency allowed. You also have more flexibility around CPU and memory options. Although, as you'll see, Google Cloud Run is still pretty limited in that department today. From the research I did in this episode, the AWS products seem more well-rounded right now. But there are limitations to the containers as a service stuff too. If you go down this route and install tons of stuff in your containers, the cold start or boot time can be really long for real-time applications, in that each time you're invoking a request, you're starting this container. So if your container takes a while to boot up, the latency will be pretty high. So you want to optimize this as much as possible. So this is my mental model of containers as a service. So what's the difference between these two categories? Well, from an end user perspective, these likely act and appear very similar. However, from a programmer DevOps perspective, the functions as a service category offers a narrow criteria for what you're allowed to do. So if you need something a little more complex, you might explore options in the Fargate or Cloud Run category. This episode will be my first look at Cloud Run, and I was thinking we should probably check out Fargate shortly too, so that we can compare things. You might be thinking, what are some use cases for this heavier weight container option? Well, say you need to do some complex image processing and you need some very custom software libraries. You could easily do this with containers. Maybe you need to do some complex data extraction and processing using custom R scripts or something. You can basically do anything you want using the tools down here, as you have complete control over what goes into the container. And there's all types of use cases for things like data extraction, conversion, webhooks, sending notifications, etc. Before we dive into much, there was a pretty good launch announcement blog post last week that outlines many of these use cases and the concepts too. It's worth reading if you're interested in this space. There were also 2 really good Hacker News threads around the topic, and there's lots of comments about the differences and similarities between Lambda, Fargate, and Cloud Functions. Even a few of the developers and product managers from the Cloud Run team were in the thread there talking about the roadmap too. So it's pretty interesting even if you're totally on AWS, as it signals where things are headed in this space. So that's why I thought it might be worth pointing out. So I wanted to jump over to the documentation pages for a minute and quickly call out a couple things, as I think it'll help explain what's happening in the demos. So when you're running your own custom containers, you'll likely want to connect to things like storage, databases, cache servers, etc., and grab or process data. This also applies to Lambda, Fargate, and others too. You likely want to check and make sure that the supporting services you want to use are actually supported, because not all of them are. So it's just something to be aware of. Next up, this page walks you through what's happening behind the scenes. So we ask Cloud Run to run a container, and it creates something called a service, and our containers are behind that. And then you can have multiple revisions of a service as we iterate on things. So an example of this might be that you build an image and you push it, then you build another image and you push it, and you use the same name. So that would be multiple revisions of the same container. Next, here's a page that chats about how concurrency works. Basically, you can control how many requests your service can handle at once, before you want things to kick in behind the scenes and scale up your container instance count. Next, we come to pricing. Cloud Run charges by the resources you consume, rounded up to the nearest 100 milliseconds, which is pretty crazy. Here's a breakdown of what the CPU and memory costs are like. Down here, there's a diagram that even helps explain how things are billed when overlapping requests come in. For smaller things, if you run the numbers here, it's likely way cheaper and less operations overhead than running your own Kubernetes cluster. Something I haven't mentioned yet is that since this is based on the Knative project, and Knative is open source, you can run all this on your own Kubernetes clusters too. So this workflow should be totally transferable off the cloud. Say, for example, you wanted to run it on your own Kubernetes cluster in a data center you control. But for me, I think the interesting part of all this is the managed service offering bits. So that's where I'm going to focus. Finally, I want to quickly call out this quotas page. This is often overlooked and it applies to AWS too. If you're looking to set this type of stuff up, make sure you check out the quotas and limits pages, as they walk you through the max CPU, memory, request sizes, etc. And these pages will save you tons of troubleshooting time when things don't appear to work like you think they should. Alright, demo time. So I have the Cloud Console loaded up here. Again, I'm thinking a few weeks from now we'll do the same demos on AWS Fargate too. So under this hamburger menu up here, you can scroll down into the compute area and find Cloud Run. So this is the web UI interface. We'll also be doing things down at the command line, but for now, my candid comments of this are it's pretty sparse, and it still looks very much like a beta. You can create a service here. We just specify the container we want to run. I'm just going to copy and paste this Hello World demo here, and then down here you can give it a name too. This was the service name. Right now it looks like the only region online that runs Cloud Run is US Central 1. But you remember those Hacker News threads? One of the product managers said this is rolling out to a larger amount of regions soon, but for right now it's just in US Central 1. So I'm going to check this box to allow external traffic from the internet into this container, and then I'm going to click Create. So what's happening behind the scenes here is that Cloud Run is pulling down the container, creating a service revision, routing traffic, and allowing external access to it. Then you get this nice little web link and we can click it. So this page is running off that container we just launched, but we're not managing any of the backend infrastructure. All of this is taken care of for us. Plus, you're only paying when you're using compute and memory resources for requests. Pretty awesome, right? So let's head back to the console. Over here, you can do things like view logs. And you can see our requests here. There's this details tab here too. But there's not much in there though. Back on the service revision page, you can see the service details, things like the container image we're using, the memory, the current connections allowed, and you can also view the YAML file here. I should mention that with this web link here, there's also an ability to hook up your own custom domains using this option here. I briefly sort of explored it, but it looked like there was a lot of hoops to jump through, so maybe I'll save that for later. So that's the high-level concept in a nutshell. Basically, take your container images and run it on their infrastructure. They handle all the back-end and under-the-hood stuff. But I'm sort of interested in running a few of my own demo containers too. So one of the first questions I had was, what's the environment variables that are exposed to your application in the container when you make a request? Well, the documents talk about it, but I thought, hey, let's run a demo and we'll actually find out for ourselves. So let's jump over to an editor and have a look at a few containers we'll be testing out. So we already looked at this Hello World example. I downloaded the example code from the documentation pages, and there's nothing really to it. Just a simple web server and Docker file. The core idea, though, is that you have total control over what you put in your containers, so you can build to your exact needs without the narrow constraints of, say, a functions as a service offering. So this is the container that'll dump all the environment variables when we connect to it via our browser. We're just grabbing the host name, all the environment variables, and then printing them out. Then here's the Docker file. We're copying our code, compiling the program, and then setting the web server as the launch command. So let's jump to the command line and actually deploy this. By the way, I've linked to the quick start documentation where you can find all these demos too. I've also posted the demos on my GitHub page, and links are in the episode notes below. Alright, so first I need to initialize things with Google Cloud since we're doing this from the command line. I don't know if you need to do this, but I'm going to set my default region to US Central 1 since this is the only region that works with Cloud Run right now. Next, I'm going to set my working project to testing Cloud Run, and that's the one I created for this demo. Now let's submit the code for building this container. What's happening here is that we're using Cloud Build to build a container behind the scenes. Maybe check out episode 58 as I go into more details of how this works there. So we can flip over to the console and watch things happening live. And here's the output of the container build process. Then when that's finished, if we click over to the Docker registry, you can see our image here. This image is what we want to deploy to Cloud Run. So let's jump back to the command line and deploy it. So let's run this gcloud beta run deploy step pointing at our newly created Docker image. It'll prompt us here for a few things too, like the name, and if we want to expose this publicly. Then it launches it and we get this link. But before we check that, let's head over to the console and verify things look like we would expect. I'm just going to refresh this page. Cool, so you can see our new service was launched here. By the way, I blurred out this area here since it has some of my account details. So let's click in here and open up that link to connect to our newly launched container. So here's the environment variables that are exposed inside our container. Mostly just application-specific stuff and nothing too interesting. I can just reload it a few times here too. The thing to note here is that you're only paying for when things are actually serving your request. So the requests are completed and we're not being charged anything. This could be pretty awesome for lots of use cases where you need something pretty complex but only need it once in a while. And you can see how simple it is. We just have a couple files, our program and then the Docker file. Alright, so what about HTTP headers? You think there's anything interesting in there? Let's find out by jumping back to the editor. I'm using pretty much the same code here, but this time I'm dumping all the HTTP headers. There's also another change here too. In the Docker file, before we were using the Alpine base image. This time I'm using the Scratch image. Since we're statically linking the Go binary here, what this means is that there's nothing else in the container except our binary. So this makes things way smaller, but also more secure as there's nothing else in here. There's no operating system. But I mostly just like this because it's sort of cool. Alright, so let's jump over to the command line and run those build and deploy steps again. I'm just going to heavily speed this up since you already know what's happening here. Alright, and it's done. Let's open the link. Cool, so you can see our HTTP headers are dumped out now too. Again, there's nothing too interesting in here. But this might help debug things. Say you wanted to get a user's IP address or something, and you were wondering what headers you had access to. Let's head back to the Cloud Console. So we now have our 3 containers running here, and it doesn't appear to take too long to deploy things. But we're doing some pretty simple stuff here without too much complex logic. But I was wondering, how small of a container could we actually create? We already tested out the Scratch image, and if we check the registry for that dump headers container, you can see it's around 4 megabytes. But I was wondering if we could go smaller. So after a bit of searching around, I found this web server written in assembly, and it's roughly 6 kilobytes. So I compiled that assembly code and created a Docker file using the Scratch image again too. As I mentioned before, the scratch image is basically a container with nothing in it. There's no operating system, directories, nothing. It's totally blank. So this should be super small. So let's jump over to the command line and run the build step here. I sped this up a little, but not much since it's super fast. All right, so let's check out the Docker registry. So this Docker image is only 3.1 kilobytes. Pretty awesome, right? Just think about this. We have an assembly web server sitting inside a totally blank Docker container, and we're deploying live traffic to it through Cloud Run. So let's jump back to the command line and deploy this thing. Again, I sped this up slightly, but it's super fast and lightweight. Let's check out the link. Pretty cool, right? I'm just going to open up the developer tools and watch the request latency in here as we reload a few times. So we're getting around 300 milliseconds per request. I guess this is the time for the container to launch as requests are coming in. Okay, so this is a super tiny container and no one is going to do this in real life, so let's try something a little larger. I created an 800 megabyte compressed file using random data. I'm going to add this into our container and see what happens. Typically with Docker containers, when you build them, the image layers get compressed. But since this is random data and I already compressed it, we're actually going to be deploying an 800 megabyte container. This is what a more complex application might actually look like, running a base operating system, your code, along with all your dependencies. So let's uncomment the line in the Docker file to add this file in. Then let's jump over to the command line and run that build step. I'm going to speed this up heavily as this step is uploading 800 megabytes over my connection here. So that took around 20 minutes. Now if we check the Docker registry, you can see our new version of the assembly container, but now we added in that 800 meg file, and you can see it's around 800 megs. So let's jump back to the console and deploy it. I had to speed this up quite a bit too, as I suspect a larger image like this just takes more time. Behind the scenes, they likely need to pull the image, find a place to run it, route traffic, etc. All right, so we now have the link. Let's open it. So you can see this is a little slower to start. And then after we reload a few times, we're getting around the same speed as before. This is interesting in that they must be doing lots of caching behind the scenes and have things prepared to boot quickly. Because this is an 800 megabyte image and it's launching really quickly here. So this is where you'd likely want to be careful in that cold starts or boot times can likely be an issue if you're running complex code or you have deep dependencies on external services that are going to hang things up. All right, that's it for my first look at Cloud Run, and we got to look at what a few similar products look like, those being Lambda, Fargate, and Cloud Functions. I really hope this trend of managed single container instances continues, as it could likely simplify lots of the low-hanging operational fruit out there. All right, so that's it for this episode. Hopefully you found it interesting. All right, thanks for watching. I'll see you next week. Bye.